Triangles where we know angle, side angle, or side angle, angle, as we've seen in the past, can be found without too much problem. Just law of sines gives us what we need to know. However, if we know two sides and an angle outside of these two sides, this will actually create an issue, which we will look at here. So we have two side lengths here, A and B, and an angle outside those two side lengths. Drawing a picture of it, I'm gonna draw the angle first. This is gonna be like 60 degrees. This is 90, so 60 is gonna be somewhere around here. So 60 degrees, we have the side opposite this angle is A. So B looks like that, and A will look something like this. So it's gonna look something like this if it actually works, which we will look at in a moment here. So the side angle situation, let's try law of sines on it. We know A is 15 and the angle opposite A is 60. We also know that B is 20. So you can solve for this thing. We get B equal to sine inverse of 1.15. But this doesn't work. Arcsine is only defined on the domain -1 to 1, which means that this has no solution. In fact, what I should have drawn here is I should have drawn a picture where we had B is 20. The angle we want to draw here is 60 degrees. And this side is supposed to be something like 15, but 15 doesn't quite meet it. There's actually a gap there. So this is supposed to be 15, this is supposed to be 20. And there's a gap there. So that's the idea here, is that it actually doesn't meet it and it does not complete the triangle. But so this case didn't work. Let's try if we worked with A equal to 18 instead of 15. That's the issue, is that the side length A is too short. Let's extend it and see what happens. Well, doing the same thing again, solving it, we get this solution here. So we do in fact get an angle for B. And C, of course, means that C is 46.26. Since we know what the angle A is, the angle B is, we know what angle C is. Using law of sines, we can solve for C using the standard law of sines approach, and we get 15.02. The issue is that when you look at a graph of sine, there's actually two solutions for this statement right here. And so let's look at that. Let's look at the graph. Sine of x, and we have this 0.96. If I zoom in here, you can see I get two solutions, 1.287 and 1.854. Those are, of course, in radians. If I show them in degrees instead, then I just did the conversion here. I get 73.74 degrees and 106.28 degrees. And that's what I have shown here. And we only got one from the sine inverse, of course, because of its restricted domain. That's always going to be the case when you're working with inverse trig functions. You're always going to have potentially more solutions than you're told. So if we use B equal to 106.26, we already solved for 73.74. So if we instead use B equal to 106.26, we can find that C equals 13.74, and solving, this would be 13.74 degrees. And then solving for C, we get this other side length here. So we actually find that there's two triangles that fit this scenario. Now, it turns out that whenever you solve for this kind of scenario, you will either have no solution or there will be two solutions just from this graph like I showed you here. The issue is that sometimes that obtuse solution, like here we have an obtuse B, and that's always going to be the case. There's going to be one acute and one obtuse. Sometimes that obtuse angle will not be valid, and you'll see that by when you're trying to find the last angle. You're going to have something that adds up to be more than 180 degrees, and that can't be. So all we have to do really is test to see if there is a solution to it. Test it if the second solution that you get from it is valid. Of course, you need to first understand that there may not be a solution, so keep that in mind. All right, let's look at these two scenarios here. We have A, B, and the side angle, side opposite A. Again, the side lengths and the angles that are named, it doesn't matter which one's which. All that matters is you have this scenario. In this case, we have side angle. This is also a side angle outside of the two sides, right? We do not have side or angle side angle, or any other combination. We have side angle. Now, let's use law of sines. So we're going to have, I'm going to do sine 60 over 21 equals sine b over 20. Okay, that means b equals, I'm going to multiply over by 20 and then take the inverse sign. And that gives me b equal to 55.6 degrees. So c must equal 180 degrees minus 60 minus 55.6. And we get 64.4 degrees. Because we did not have an error when we did the inverse sign to find b, that means we know there's at least one solution. Now, how do we know if there's two solutions? The way we can do that is look at this b and take 180 degrees minus what we got for this one. That will give us the obtuse angle that is also a possibility. So 180 minus 55.6 gives us 124.4 degrees. And to find c, so that this is for the other solution. So c equal to this works perfectly for this and this stuff. And then we can continue from there in just a moment. But we're just checking to see if there's two solutions. 180 minus 55.6 is this one here, which means that in this case, this is what b would equal. In this case, we take 180 minus a minus b. A is 60, b is this. But hopefully at this point you can see, well, 60 plus 124 is over 180. This is actually going to be, if you do that, you're going to get negative 4.4. And an angle can't be negative 4.4 in a triangle. So we know there can only be one solution. This second solution doesn't work. Okay, going back to our original solution here. We know what the angles are, and we know what two side lengths are. Let's find the third side length. To do that, let's do a over sine a is sine 60 equals, let's see, it's going to be c is what we're trying to find. Sine c is sine 64.4. And solving for c, we're just going to multiply sine 64.4 over. And I get c equal to 21.8. And so I have my triangle solved. I have a, b, and c, and angles a, b, and c. Here we have a very specific a, and then b and a, angle a is there. Do sine 60 over a is 17.320508808 equals sine b over b. So sine b must equal, and actually this ends up being equal to 1. It's not quite 1 when you type it in a calculator, but it's supposed to be 1. That's the whole point of doing this scenario. And why is this important? Because sine b equals 1 only at one place. There's only one possibility for this. Even though I told you most obliques have two solutions, this one has specifically only one because it equals 1. Sine of b equals 1 when b equals 90 degrees. So in fact, we do not have an oblique triangle here. Instead, we have a right triangle. Which means actually we don't have to use law of sines. We can just use right triangle trig. So this is 90 degrees. That means the hypotenuse must be 20. If a is 60, then that means opposite that is going to be the 17.32050808, which means this one here has to be 30. And that means we're going to have, this is supposed to be 1 root 2 that. So this should be 10 because of the 30, 60, 90 triangle. So you can, of course, use law of sines to calculate this thing. It should work. You can also use right triangle trig. All right, there is great references in the Precalculus book in OpenStax. This is a great image to show you all the possibilities. What I just showed you was a right triangle and a triangle that had 1, where A was greater than or equal to B. That's what this first one was. A is greater than or equal to B, so we only expect there to be 1 solution here. And when A equals the height of this triangle, which is why this was so specific, that's when you have only 1 solution. No triangle, I showed you that in the very beginning, where you have A is less than the height of the triangle. You can, of course, just try law of sines on this one. And when you do that, you're going to get a syntax error or something like that in your calculator. You're not going to be able to continue. And the true triangles, really, this is always the case you should be considering. There's probably going to be 2 triangles if you try it and there's no solution, because you have, like I said, sine inverse of something greater than 1, like 1.10. This can't be possible because sine can't have anything bigger than 1 in it. But with 2 triangles, you can always check. You can always assume it's 2 triangles, and when you check the second solution by doing, so you solve for, in this case, you're solving for B. They're using alpha, beta, and gamma. I've been using alpha, A, B, and C. It's just the same thing. Don't be confused by their notation. In this case, B or beta. You're going to find one of them. You're going to find this one when you do law of sines. And then all you have to do is do 180 minus B. And that will give you this angle here. And if that does work with A or alpha, you add them up and you can find this third triangle, then you have 2 solutions. If you add this up and you don't, then you actually only have one valid solution. And in this case, you can see that really everything depends upon the height of the triangle. If it meets, if it is exactly the height, or if the height is less than A, that there's 2 solutions there. Of course, this is also where the height is less than A, but there's only 1 solution that's possible. That's, of course, if A is greater than B. So keep this image around. Keep thinking about it when you're working with this. This only really ever works for side angle. That's what you're going to be looking at. And with this information, now we can look at filling out our table again. We have this ambiguous case here. These 2 we looked at in the previous video. And of course, this you can never find. But to find these last 2 sides, or these last 2 scenarios, we need to know the law of cosines.